So we're in chapter 1 of your chemistry book, and we're going to be talking about dimensional analysis. Don't let that word stumble you because it's something we do every day in our life when we're trying to figure things out, especially with conversions and to convert something into something else. So how do we do this? Basically, dimensional analysis has to do by multiplied by the conversion factor that equals a 1. Because anytime you multiply a number by 1, it's always going to equal the number. If you have 475 and you multiply it by 1, it's going to be 475. So this way we can cancel different factors out. So it's to cancel units in the numerator and the denominator, these unwanted units, to get rid of them, and so that we can find the exact answer. Now, I could say this, but it's really important that I show you how to do this. So examples of reciprocals. You know what reciprocal is? It means basically where the numerator and the denominator are turned around. And if you multiply reciprocals, it's always going to equal 1. We know that. So 1 kilometer divided by 1,000 meters times 1,000 meters divided by 1 kilometer. And if you multiply that out, bing, 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 you could actually cross this number out and cross this number out and cross this number, and you get 1. They would equal 1, right? So this multiplying by 1 will not change the value. So you'll have the volume of the unit times the conversion factor, which is going to equal the value of a new unit. So let's really see how we do this. Let's have some fun here, okay? So how many minutes are there in 2 weeks? I'm going to ask you that question. So Ellie, how many minutes are there in 2 weeks? And you're like, how do I figure this out? Or Izzy will say, okay, I have to multiply this by the days and this. So let's write those conversions out. We have 1 week equal 7 days. We have 1 day equal 24 hours. And we have 1 hour that equals 60 minutes. So now the fun part is to put them in these fractures, to do this dimensional analysis. So we take the 2 weeks, we put 2 weeks down. And now at the numerator, we have to have weeks in order we can cross this weeks out and get rid of the weeks. So we have 2 weeks, so we know that 1 week equals 7 days. So now we can cross the week out. But now we have days. So now we're going to think, well, what about days? Well, let's put day in the denominator. 1 day equals 24 hours. Oh, okay, that's good. So we can get rid of the day here. And now if we look here, we have hours now. And so we have 1 hour equals 60 minutes. Okay, now we're in minutes. We need to know how many minutes. So we crossed out the hour, we crossed out the day, we crossed out the week, but we have left is just a minute. So now we have to now have a whole bunch of numbers here. So we need to multiply all these numbers. On the denominator, we have 1, right? So we can say 2 times 7 times 24 times 60. So we multiply that out. If you multiply those numbers out, you'll get 20,160, and then you have left minutes. So 20,160 minutes are in 2 weeks. Isn't that kind of fun to do? Yeah. So let's talk about the questions a little bit here that you have in the book. It talks about precision and accuracy. One thing you need to know is accuracy misses the mark. Precision is not talking about missing the mark. Precision is how each one, say you have a whole bunch of people measuring, and they're all measuring almost the same. That's high precision. All these guys are measuring the same, right? The same number, and they're coming up with the same number. But it doesn't mean that they all can miss the mark, right? So you can have a low accuracy even though you have them having a good precision and they're all the same. You know, if they all had a number like close to 116, 116, 116, all of them had that same number, but the number was 98, you'd have a poor accuracy because they missed the mark. But their precision would be good because they were all of them were quite alike, right? So that's the difference between precision and accuracy. Number 2 talks about uncertainty. The only way you can be certain is if you're, number 1, counting. So you're counting like 1, 2, 3, 4. Then you can be sure there's that many, right? If you're counting. Or you're multiplying basically, 2 plus 5, that kind of thing. but that's the counting that can give you exact. It's the only way you can be exact is if you're counting it out, or you have defined values, like how many inches in a foot, 12 inches. Those are defined values. Only defined values in counting. Otherwise, you're going to be uncertain. If you have water, you're trying to measuring water or gas or something, it's going to be very uncertain. But you will be certain if you're counting and you have defined values. Those are the only ways you're going to be exact. Now let's talk about the standard international units. So what is the standard international? You need to know these for your test. What is the standard international unit to measure length if you're going to measure out lengths? No, you can't measure them in in feet or yards, but if you're measuring length, the standard is going to be in meters. So the standard comes actually from France, so in that matter. So length is going to be in meters. Now, if you're measuring mass, I'm not talking about weight. Remember, mass and weight are different. Mass measures, looks like the weight, but weight has to do with gravity. Because if you take your weight on the moon, it's going to be a lot lighter than it's going to be here, right? So weight has to do with gravity, but mass has to do with basically the mass, how much the object, not volume, but how much mass is in the object. And this is always measured in kilograms. So, if you go on an international flight and you want to measure your luggage, you think, well, I have 50 pounds. Well, they say, no, we need to figure this out in kilograms, because kilograms is going to be the mass, the standard unit international of mass. Volume is in liters. So if you have a quart, it's not going to be quart, but actually you need to know that a liter is bigger than a quart. So if you have a liter of soda and you want the most of it, would you buy a liter or would you buy a Coke? Or would you buy a quart? So of course you buy a Coke, but if you would buy a liter, because a liter is more than a quart, right? So liter goes with volume. Length in meters, mass in kilograms, liters and volume. These will be on the test. These are probably on the test too. 1 centimeter is 1/100th, and 1 millimeter is 1,000th. 1 micro is 1/1,000,000th. It looks like a weird little, slanting N or something. Slanting little M is a micro, which means 1/1,000,000th. Okay, those are small numbers. You're getting really small. A centimeter is going to be 1/100th of a meter, right? And you get littler and smaller and smaller. Now, when you want to get bigger, you're going to say, I have a megaton. That's a 1,000,000. That means a million. Mega means a million. I have a kilo. That means you have 1,000. Or I have a nano. That means I have 1 billion. You need to know these for your test too. So let's go on to a few other things here. I'm going to move this here. So your application, you're going to need to know this too. So this sign means density. So density is going to be P. It's a weird little P. It means density. It doesn't even look like a P. You have to make it like a slanting little weird P. A little P equals mass over volume. So when they give you the mass, which they're going to give you a mass, if they give you a mass of 2,790 grams, and then the volume is in milliliters, it can be in milliliters or it can be in cubic. Well, anyway, this one's in milliliters. So you have this divided by this to equal. So you take the mass here divided by the volume, and you're going to get the density. If you divide these two numbers, you'll get 13.6, and that's going to be grams per milliliter, because grams per milliliter, mass is in grams, and then volumes in milliliters. So you have 13.6 grams per milliliter. Now I divided it out here, 205, so I got 13.6. So anyway, so just know, when you want to find density, it's going to be mass over volume. You just plug it in as you do algebra. Just plug in those numbers. So let's do the next one. Your density, this one is the same, except you have the density. So instead, so we know the P, the density, is going to be 1.5 grams per cubic for cubic centimeters, which is the same as milliliters, but here we go. So we have 1.5, and then the mass, m, we don't know the mass. So we can put the mass as m, and then we divide it by 50 cubic centimeters. So basically here we have 1.5 and times 50, because we're gonna actually, we divide it by 50 over here, we multiply on this side, so 1.5 times 50 equals the mass, which is going to be 75 is going to be the mass. So the mass is going to be 75 grams. You just fill in this whole thing. Now you can change this here if you want and say, since we have the density, you can say mass equals P density times volume by just moving these numbers around, moving this around. So it would be, mass equals P times volume. So you're just going to basically times this number by this number, and you're going to get the mass. It's basically the same equation, but filling this in. Okay, temperature. We need to know how to do temperature, right? I hope you remember those equations. So here we're going to change. We have 37 degrees centigrade to kelvins. And so we know that our equation is centigrade equals Kelvin minus 273.15. Just remember that. So we have 37 equals K minus 273.5. Well, since it's a minus on this side, you need to add it to this side. So we have 37 plus 273.15, and that's going to equal 310.15. And Kelvin never has degrees, but it's going to be 3.1. Kelvin is the absolute zero scale. There's 3 different scales: Fahrenheit, centigrade. Now we're just dealing like this. So basically you need to know this: centigrade equals Kelvin, absolute zero, minus 273. Okay, say this is one will be on your test. So you have 100 degrees centigrade. So basically all you have to do is add this 273.15, to 100, and that's what you get. So 100 degrees centigrade would be 373.15, so, but here how easy it is. Basically it's Kelvin minus this, but whenever you minus, you're going to add it. So even though it says a negative number here, it's going to end up a positive number. Okay. 3B, change 25 degrees centigrade to Fahrenheit. Okay, temperature Fahrenheit equals, now since I always think, since temperature Fahrenheit is always going to be a bigger number than centigrade, right? So if you have 0 degrees freezing, and 32 degrees, so you're going to know Fahrenheit's going to be a bigger number. So that means a bigger number, I'm going to times it by 9/5 instead of 5/9. So I have Fahrenheit equals 9/5, and then take your centigrade, 25 degrees centigrade plus 32. So Fahrenheit's going to equal, first I'm going to take 9/5 times 25, and I did there, and I got 45, right? The answer right here. And then I'm just going to add 32, so the temperature is going to be 77 degrees Fahrenheit. Now I look up here and I say, oh, 25 degrees centigrade, that sounds good. If I was in Australia, it would be 25 degrees centigrade, but I'm here, it's going to be 77 degrees Fahrenheit. So I kind of check it at the end to see if it matches. But just remember, whenever I'm changing from centigrade to Fahrenheit, I'm going to have a bigger number, so I times it by 9/5. Okay, now we're going to change. This takes 2 things, because we're going to change a negative degree Fahrenheit to Kelvin. Well, we don't have any Fahrenheit changing to Kelvin, so we're going to have to do 2 equations. So first we're going to have to change it to centigrade, and then we're going to have to change it from centigrade to Fahrenheit, right? So the 3 different things. So what I did, if I have, here's my equation again. Now degrees centigrade, remember it's going to be going, it looks like it's going is a smaller number. I'm going to do 5/9 times degrees Fahrenheit minus 32. So I take the minus 5 degrees minus 32, and I get minus 37, right? And now I'm going to times it by 5/9. So I'm going to get a negative number here, and as I calculate it, it's going to be negative 21 degrees centigrade. That's going to be what it is. And so then I take that negative 21 degrees centigrade, and I go over to my scale here. Centigrade equals Kelvin minus 273.15. So I have negative 21 degrees, and then I'm going to add the 273 to the negative 21. So basically it's going to be 273 minus 21, which is 252.15 is going to be the Kelvin. So first you change it to centigrade, and then you change it to Kelvin. Okay, you might have one of those. Okay, now let's do, let's see. You have some questions here. Let me see if I got these right. Sorry. Pull this down here so you can see. I don't know what this first question was here. Oh, here we go. 30 centimeters to meters. So basically, 30 centimeters to meters, you're going to multiply it by centimeters by 100. So you're going to multiply 30 by 100, and what are you going to get? Are 30 centimeters to meters? I mean, did I say multiply? It's 1/100th. So you're going to divide by 100. Okay? So you're going to get 0.3 meters. There's 1/100th. 30 centimeters, 1 centimeter is 1/100th of each. So I have 30 centimeters and 1 meter times 1/100th. So you have 30 over 100 equals 0.3. So 0.3. So if you're going to change it to meters, it'd be 0.3 meters. Okay, here's another one. 1.45 days to seconds. So this we have here we did our dimensional analysis. So we have 1 day equals 24 hours, 1 hour equals 60 minutes, okay? And then 1 minute equals 60 seconds. So we have 3 different things to go through. So let's go through these. So we have 1.45 days, 1 day equals 24 hours, cross out the day, now the hour, cross out the hour, 1 hour equals 60 minutes, and then 1 minute equals 60 seconds. So now we're going to cross all of these out, and we're going to multiply them out. And so we have 1.45 times 24 times 60 times 60. And if you can use your calculator, you get 125 to 280 seconds by multiplying these out. I kind of multiplied them out here for you, but here's the answer here. So basically you're going to multiply all of these numbers here to get, and you're going to end up with seconds. We want to know how many seconds in 1.45 day, right? And that's how many seconds. Remember how we did the dimensional analysis, just putting the days at the bottom, putting the hours, and putting the minutes. So this one is, you want to change 0.00590 grams to milligrams. And so we know that milligrams are small, they're 1,000th, right, of a gram. So how do we do this? So basically what we're going to do to change it to milligrams, grams to milligrams, or 1,000th of it, we're going to move it over to make it smaller, or, basically move over 1, 2, 3 places. And so right here here's the number divided by 1,000. We're going to move over, get it smaller. So here's the number here, 1, 2, 3 places smaller. Okay. So here we have 5 centimeters a second to kilometers per hour. This one's kind of a hard one, so I did this a couple times, but here's how you do it. I'm going to put a little bit. So 5 seconds. Okay, so there's going to be how many centimeters, because we have centimeters per second. How many centimeters is going to be 1/100th of a meter, right? So, and then how many meters, we cross out meters, is 1,000th of a kilometer. So here we put these down, and we crossed out the centimeters and the centimeters and the meters, right? Because we want to know kilometers. And so we figured it out by multiplying 5 times 0.01 times 0.001, and we got this number, 0.00001 kilometer. Okay, the kilometer. But now we have it in hours, not in seconds. And so now the hard part is to figure out how to put it in to find out, we have this kilometers. That's how many kilometers in a second. Now we want to know how many kilometers in an hour. We're going to have to times this by how many seconds are in an hour. Well, there's 60 seconds in a minute and 60 in an hour. So you multiply, so you get 360. So you're going to have to multiply this number by 300 and so I have 0.001 times 3,600 where we multiplied in an hour, and what I got is 0.036 kilometers per hour. That's pretty hard one. You probably won't have that hard one on a test where you have to really think in 2 dimensions there, but that's dimensional analysis. So that's the end of this section, and we'll get into the next section.